The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone, or good morning. Welcome to our fourth lecture of this batch. So we have Mazhar, Rakesh, and Srinivas. Hi to you all. All right, so I guess we can start in next 1 minute because I can see that people are still joining in. Before that, I just want to confirm that you can see my screen and the audio is proper. And in the meantime, I just open the slide. Yeah, thanks for confirmation of us. Okay, so till yesterday we were discussing the concept of ELB, where we were at the midpoint where we had already launched, or I would say we were on the fourth step of launching our ELB, or the Elastic Load Balancer. So what I will do is I'll just start my instances, and we'll start configuring our Elastic Load Balancer. So I have discussed most of the configuration part, I guess about 50%. So we'll start from the, I would say, we'll start from the fourth step of the ELB creation. So I go to load balancers. Now I've already discussed all the concepts till fourth step yesterday. So I'll just perform the configuration without explaining it, because I already explained that yesterday. So I am just going to the fourth step, adding the subnets. I'm choosing my existing security group. And security settings, configure health check. I guess someone has raised their hand. Mazhar, I'll come to a question later on because I've just started. Okay, so once we are done with this topic, then I'll take your question. Okay. All right. So we were at the fourth step. Or we have done till the third step, so we'll start with the fourth step now. This is the fourth step where we have to configure the health check of our Elastic Load Balancer. Now, as we have discussed yesterday, what's the health check that's being performed by the Elastic Load Balancer? The health check that is being performed by the Elastic Load Balancer, it works in such a way that, let me just take the pen to make it more understandable. So let's suppose if this is your load balancer, or ELB or LB, and this is your instance. What happens is that the load balancer sends a health check message to your instance, and it waits for the response. Right? Now, if the load balancer sends the health check traffic to the instance, and if the load balancer does not acknowledges that health check traffic, the load balancer gets to know that, okay, there's something wrong with the instance. Just in case if this instance is unhealthy, it is down, it is shut down, it is stopped, it is in frozen state, there can be multiple reasons that this instance is not responding. In that very case, if the load balancer gets to know, okay, there's something wrong because the instance being unhealthy is not responding to my queries, I should go ahead and stop sending the traffic to it. Fine. Now the responsibility of the Elastic Load Balancer does not end over here. It will keep a track or keep an eye on this instance. So after some time, let's suppose after 15 or let's suppose after 30 minutes or half an hour, this instance comes back up, right? What happens in that case is that the load balancer will start sending traffic to it again, finding the fact that, okay, this instance is being up and running now, it is healthy. The load balancer will start sending traffic to it. Based upon the same concept that I have discussed right now, we configure the entire health check options over here. Okay, so I'll discuss all these things one by one. First thing first, we have to select the ping protocol and the port that will be used to send the health check traffic. So by default, it is also recommended that you use the HTTP over port 80 to send the health check traffic to instances. Okay, so this traffic or this protocol or the port will be used to send the health check traffic. So we will use HTTP traffic over port 80 to send the health check ping messages to our instances. Now, the thing is that your instances, when you're sending the traffic to instances, you need to define on which page of your instances the traffic should hit. Normally, we use the default web page of our website. For example, /index.html, it can be a / depending upon what's the default web page you have defined for your web server. So either it can be a / or it can be index.html. Right. Once you define what's the ping protocol, port, and the path, it's time for you to define the advanced details. In the advanced details, you have to configure something called the timer values. What are these timer values? In these timer values, we will define that, okay, what's the response timeout interval. So I'll discuss all these things one by one. First thing first is called the response timeout. That is by default of 5 seconds. Now you can tweak into this timer values depending upon what's the requirement of your application. But these are the default values that you can stick to if you want. So this thing, response time, means that, for example, if this is your load balancer, and the load balancer sends the health check to your instance, like this. Now, once it sends a health check message, so give me 1 second, let me just draw this again. So this is your load balancer, and this sends the health check message to your instance. Now the load balancer will, once it sends the health check message, it will receive, or it will, this load balancer, once it sends the health check message to the instance, it will expect an acknowledgement. Because if the instance is healthy, it will acknowledge to the health check ping message sent by the load balancer. Now, if this instance does not respond within 5 seconds, if the instance does not respond within 5 seconds to the load balancer's health check, the load balancer will time out this message. It will say, okay, I'm timing out this message. It's time for me to send another health check. So the request timeout means that it is a time period during which the instance, if the instance does not respond to the load balancer's health check, the load balancer will term that instance, or not term that, it will time out the message, right? Because if it's not receiving the acknowledgement, the load balancer will say, okay, I'm timing out this message, I'm dropping this message. It's the same thing. For example, let's suppose in day-to-day scenarios, let's suppose if you pick the phone and you call someone, right, and someone on the other side picks up your call. If you don't hear the response, you say, hello, are you there? If you don't get the response from the other side, you disconnect the call. It's the same thing with the load balancer. If it doesn't receive the response from the instance, it will say, okay, let me disconnect this message. Right? That's called the response timeout. Next we have something called interval. What is an interval? Interval is the time gap between two consecutive health checks. By default, it's 30 seconds. So by default, the load balancer, it will or it should send the health check messages to all your instances after each 30 seconds. After each 30 seconds, the load balancer will ping your instances and get to know the health check or get to know the health of those instances. So for example, after let's suppose 30 seconds interval, this load balancer will send the second health check. After 30 seconds, the third health check. So the interval is the time gap between two consecutive health checks. Okay, so this is your load balancer, and after each 30 seconds, it is intended or it is bound to send the health check messages to all the instances, depending upon what kind of instances are reporting to it. Next, we have something called unhealthy threshold. It is 2. Unhealthy threshold means after how many consecutive times the instance should be declared as unhealthy. So let's suppose this is my first health check, this is my second health check. For 2 continuous or consecutive health check, if this instance does not respond, might be it is down for some reasons. For 2 consecutive health checks, if the instance does not respond to the health check queries, then the load balancer will say, okay, there's something wrong. This instance is unhealthy now because for the 2 consecutive times it is not responding to my queries. This instance is unhealthy. It is better that I should stop sending the traffic to it. It will stop sending the traffic to it. So unhealthy threshold of 2 means that the load balancer declares an instance unhealthy after 2 consecutive times. You can increase or decrease this value depending upon your requirement. Next, we have something called healthy threshold, which is by default is 10. It means that after how many consecutive health checks, so let's suppose now, for example, till the second health check, this instance was not responding. Might be it was restarting during that point of time. Now, after a few minutes, this instance comes back up, right? Now, for 10 continuous health checks, if the instance starts responding to the health check queries, now, for example, this is 1, 2, and let's suppose this is my 10th health check, or I would say, after 10 consecutive health checks, if the instance start responding, or let me do one thing. So let me just wipe this out. So if this is your load balancer, and this instance was previously it was failing, but now this instance has come back up. So from 1 and up to 10 consecutive health check, if this instance that had failed before, it has started responding, the load balancer will say, okay, instance, you are fine now. From my perspective, you're healthy. So I assume that you're healthy now, and I will start sending the traffic to you. So that's called the healthy threshold, which means the instance that failed the health checks before, if it comes back up, for 10 consecutive health checks, if the instance starts responding to the load balancer's query, the load balancer will assume that instance is healthy. It will declare it as healthy, and it will start sending the traffic to it. So these are the advanced details. To summarize, response timeout means that it's a time interval during which if the instance does not respond to the health check queries performed by the load balancer, that message is timed out. Interval means it's a time gap between 2 consecutive health checks. Unhealthy threshold means after how many consecutive times an instance that is not responding is declared as unhealthy, or after how many consecutive health checks it should be declared as unhealthy. Healthy threshold means if the instance comes back up, after how many times or how many health checks it should be declared as healthy now. So these are the timer values which are there by default, you can tweak in depending upon your requirement. Okay, so that's the health check. Any questions, any doubts regarding this step 4? Any questions, any doubts? Okay, yes, Mazur has raised the hand. Mazur, I'll just put you off the mute. What's your question?
Yes, sir. Yesterday I have not attended the class, and I could not understand these steps of practical session.
Mm-hmm.
Yes. So, what can I do now for yesterday class?
See, yesterday's class, you can see the recording. Yesterday's class, you can see the recording and see the concepts.
And today's practical of this configure health checkup and load balancer.
See, at least you can see that. At least you can make note of the points that I'm discussing right now, right? And once you see the previous class recordings session, you'd be able to adjoin and relate both these concepts.
Yes.
Okay.
Okay. Thank you.
Yeah, thank you. Rakesh is saying, do we change these parameters in production or keep like as it is? Rakesh, these are default values. Depending upon the requirement of your application, you may change it or you may keep it as it is. There is no recommendation from the Amazon Web Services side. These are default values. It's up to you whether you want to change it or not. You can either lower it down or you can increase it. All depends upon your requirement. Okay. So I guess these timer values are pretty much clear. Okay. We have one more question. Srinivas is saying, so these will be common for all the instances. Of course, Srinivas. These will be applied for all the instances that will be reporting to the load balancer. So let's suppose if 10 instances are reporting to this load balancer, it will be applied to all the 10 instances. Okay. No, Srinivas, there is no way that we can keep different values for different instances, because in that case that will somehow hinder the purpose. So your question is there any way we can keep the different values for different instances? I don't think so. If you think that, okay, there are some group of instances that you want to keep some different values, then you have to create a separate load balancer for that. That's a workaround for that. All right. Because these settings that we are defining for the load balancer, not for the instance, right? So just in case if you think that some group of instances need some kind of special treatment or some different kind of timer values you need to apply for it, in that case you can use another elastic load balancer. Okay. All right. So let's go ahead and click on Add Instances. So at the bottom right corner, if you see my cursor over here, I click on Add Instances over here, and I'll just add my Linux instance 2 and Linux instance over here that are running in two different AZs. If you see over here, my Linux instance 2 is running in US West 1B, whereas this Linux instance 2 is running in US West 1C. So these two different instances are running in different AZs. Now, I'll discuss this concept. Enable cross-zone load balancing over here. Now we need to check mark this option. Enable cross-zone load balancing means that you want to enable the traffic routing between different AZs or availability zones. So by default, this option is checked. You have to keep it checked marked. Don't uncheck this option. Otherwise, the elastic load balancer would not be able to spread across the traffic or scatter across the traffic across different zones or different AZs. Now we have, this is quite important, enable connection training. Very important concept, and this is very important from the examination perspective. What is a connection training? Connection training by default, it is 300 seconds, which is equal to 5 minutes. Now I explain you what a connection training means because it is quite important from the examination perspective. See, let's suppose that if this is a user, and he is sending the traffic directly to the ELB or the load balancer or the LB. Load balancer is the same thing, and these are the two instances reporting to it. They can be different AZs or the same AZ, depending upon what kind of configuration you have applied. Now, what happens is that let's suppose that something wrong happens and the load balancer loses the contact towards both these instances, which means the load balancer is clueless because none of the instances is not responding. Both these instances might be down, or there's something wrong at the back end that both these instances are not performing as intended, and they are not responding to the health check queries performed by the load balancer. So right now the load balancer is in a state of confusion. Now during this time when this thing is happening at the back end, the user sends the traffic to the load balancer. It sends the web traffic to the load balancer, expecting that the load balancer will redistribute the traffic to the instances at the back end. Now, in this state of confusion, the load balancer will use this concept called connection training. What it will do, it will say, okay, both these instances are not responding. I can very well understand. Give me 1 second. So if both these instances are not responding, what should I do? So in that case, the load balancer waits for 300 seconds and holds this user's traffic of the session. For next 5 minutes, the load balancer will keep the hold. It will know. It will grab the user's traffic or the query for next 300 seconds, and it will say, okay, in the meantime, in the 300 seconds, I'll keep a check on both these instances. If any one of these instances come back up, I'll just route this traffic to it. For example, during the 300 seconds or 5 minutes time, when the load balancer keeps on looking for if any of the instances comes back up, let's suppose if this instance comes back up, the load balancer will quickly send over the traffic to this instance. Right? So the connection training ensures that if any one of the instances is down or it's not responding to the load balancer's health check query, and it is not reachable from the load balancer's perspective, the load balancer will hold the user's session for next 300 seconds by default, and it will keep on hunting for the healthy instance. If any one of the instance comes back up, the load balancer straight away sends the user's traffic to it. So this is called the connection training. By default, it is 300 seconds or 5 minutes. You can increase or decrease its value depending upon your requirement. This is quite important from the examination perspective because it comes up in the form of question. So that's called the connection training. Any question? Any doubts? To this point, any questions, any doubts, please feel to let me know. No? Okay. So once we have a question right now. Okay, yeah, a very good question, Rakesh. I didn't discuss this point. Thanks for reminding me. Rakesh's question is, what if the instance does not comes back in 300 seconds? Rakesh, if within 300 seconds or 5 minutes, if any one of the instances does not comes back up, the load balancer will get back to the user, giving the page cannot be displayed. In a layman term, the load balancer will respond to the user saying, "I'm sorry, I'm not able to accomplish your goal of getting to a website. The page cannot be displayed." Okay. So now, once we select both these instances, we select the cross-zone load balancing, we select the connection training. It's time for us to click on Add Tags. It's just to know, it's a kind of a tag values for our resources to help organize and identify them. It's a, I would say, an optional thing. I can skip this step. I can click on Review and Create. I can review all the options, but I don't think we need to change anything as of now, and hit Create. So now my load balancer is being created. It's done. Right? Now, once the load balancer gets created, it takes some time to boot up. To boot up means that to get into the service. Now, very important thing, very important thing, and you have to keep one thing in mind, that whenever you perform the configuration or the DNS routing, you would choose the DNS name of your ELB. Plain and simple. You will use your Elastic Load Balancer's DNS name. You will never use its IP address, because as per the AWS documentation, the IP address of the load balancer keeps on changing at the back end. You can see over here, if I'm, let me just highlight this thing. Note, because of the set of IP addresses associated with the load balancer can change over the time, you should never create a record for a specific IP address. A record means that never route the traffic to the IP address of your ELB. Route the traffic to the DNS name, right? So you use a CNAME record, which means that you will route the traffic to the DNS name of the ELB. Because at the back end, the Amazon Web Services, they keep on changing. They keep on changing the IP address of your ELB at the back end. So let me see what's the IP address I'm getting as of now. So I'll just perform my NS lookup. NS lookup. And I just copy and paste the DNS name of my load balancer. Okay, so this is the address. Okay, I think we're not getting as of now. Hang on 1 second. It will sometimes it takes some time. I don't think that these are the right IP addresses now. Let's wait. Kalyan, question is, did we discuss the Amazon Route 53 for DNS failover for ELB yesterday? No, Kalyan, we didn't discuss that. I discussed the Route 53 once we start discussing our networking components. Okay. Let me just perform the NS lookup again. Okay. Hang on 1 second. So this is the IP address we're getting for the load balancer, and this is subjected to change after some time. Usually we get two set of IP addresses. I'm not sure why we're getting one. So 50.18.215.78 is the IP address of my Elastic Load Balancer, right? Which will change after some time. So I should always route the traffic to the DNS name of the load balancer, not to the IP address. Right? Now, this is an internet-facing load balancer. I can see the instances over here that I've chosen to be pulled to the Elastic Load Balancer. Now, ideally, they should show out of service. They should show in service. I'm sorry about that. In an ideal situation, they should show up as in service. Now they're showing as out of service. Why? Because I'm not running any application on these instances. I haven't defined any of the default web pages on these instances. That's why they're showing out of service, which is quite okay because there's no application or any default web page I've configured on these instances. Otherwise, they should show as in service. You can edit the instances and you can add or subtract the instances from here. You can add or delete the AZs from here. It's up to you. You can edit the health check options. Now, likewise, we have seen the EC2, your ELB is also being monitored by the CloudWatch. Security group, you can change it. Listener configuration tags, right? Now, apart from that, there's one important thing. It's called stickiness. Let me show you that. This one. Stickiness disabled. I can hit edit and I can enable the load balancer generated cookie stickiness for, let's suppose, 300 seconds. What is stickiness? Stickiness means, let's suppose, let me just take an example. Let's suppose if this is a user. This user is sending the traffic to your ELB. From the load balancer, it is sending the traffic to the instances. If I enable the stickiness, let's suppose I enable the stickiness for 300 seconds. That's it. That is equal to 5 minutes. What happens is that I enable a capability so that if this user sends the traffic for the first time and this lands to this instance for the very first time. Let's suppose this is my instance 1. This is my instance 2. So when this user sends the traffic to the load balancer and for the very first time he gets to the first instance, for the next 5 minutes, this instance will cater to the user's requirement. Which means if the user within the next 5 minutes or 300 seconds, if he keep on refreshing the page, his request will always go to the instance 1, not to 2 for next 300 seconds. The default behavior of load balancer is that it redistributes the traffic and load balances the traffic. So in an ideal situation, it should send first stream to 1 and second stream to 2, third stream to 1 and fourth stream to 2. Which means that the default behavior of the load balancer is that it should send the equal amount of traffic to both instances. We are somehow taking that default behavior from the load balancer and keeping it out for 300 seconds. So for next 300 seconds, if a user lands to the first instance, if he keeps on refreshing the page or if he keeps on opening the web page again, going to multiple pages, the first instance will cater to his requirement for next 300 seconds. This is called the stickiness, because the load balancer will save a cookie setting on the user's browser, which will enable him to get to the same instance for next 300 seconds, depending upon the timer values you have defined. Once this 300 seconds are over, then the user request might go to the second instance. Now you might be wondering why we need to do that. Sometimes your requirement is that a user should stick to the instance for some amount of time. For example, in the banking applications, now whenever you perform the transaction, whenever you're doing paying a credit card or debit card transaction, you get a page. Don't refresh the page during the transaction because they don't want that session is cancelled out and you may land to another web page or another web server. It is the same thing. You want the users to stick to a single instance for some amount of time. That is called the stickiness. So please make a note of it. stickiness is quite important as we have the connection training. Sometimes the question comes up in the examination. Okay. So that's it. So this completes our ELB, or the elastic load balancer. It is quite important for us to know the know the concepts and everything. So we have done the entire thing. We have done the theory and the practical of it. Any questions, any doubts, please feel free to let me know, because now I'll just give you an exercise to do it yourself. In the meantime, I'll request you to please open your AWS Payment Console. I'll just show you the steps, and I'll give you like next 10 or 15 minutes to perform the load balancer configuration. Till this point of time, any questions, any doubts, please let me know. So this our load balancer is being completed now. So I guess all you guys have opened the AWS Payment Console. I'm sorry, I was not. I just got disconnected for a while. Let me just share my screen again. I'm sharing my screen again. Sorry about that. I got disconnected. The GoToWebinar tool it was frozen, and it quit unexpectedly. Okay, so when I was there, okay. So I guess all you guys have opened the AWS Payment Console, right? That is being opened right now on your screens. Now, I'll just walk you through some simple procedure to launch your instances using the script. So I've copied and pasted that script on the chat window. I'll just do it again. So this is the script that you need to run to install a simple PHP web application on your instances. So I'm just copying and pasting the script again on the chat window. Now I'll just walk you through the steps to launch your instances. I guess till this point of time, all you are aware how to launch instances. Okay, but what you can do is you can just see what are the steps I'm doing, and I will do this twice because I will launch 2 instances. So you have to follow along what I'm trying to do right now. Okay. First thing first, I click on launch instance. So you can choose any one of the regions of your choice. So go to EC2, click on launch instance, and choose the first one, that is Amazon Linux AMI. This is the one that you have to choose, right? And hit on select. I guess we all are on the second step. Once we are on the second step, we have to go ahead and choose the t2.micro as our instance type, because this is a free tier eligible instance type. Now I would request you to all follow these steps, because once this lab is over, I'll ask for the output from any one of the persons. I'll pick any one of the persons and ask for the output. So I'll ask for the DNS name that is getting it, and just try that out on my desktop. Okay, so please don't skip please don't skip the step. So just choose t2.micro as instance type. Click on configure instance details. I guess we all are on the third step now, right? On the third step, you have to do two settings. Two things you have to change. First thing, in your list of the subnet, choose the first subnet. I'm not sure what kind of region you have chosen right now. So to be on the same page, choose the first subnet in the list. That's it. Right? And once you choose the subnet, scroll down. At the bottom of your page, go to Advanced Details. Once you go to Advanced Details, choose as text and copy and paste the script that I've given to you. In this way. Take your time and do that. I guess we have done this step. Just in case, if you're stuck somewhere, please let me know. Yes, Mazuri, you have raised your hand.
Hello, yes sir. Sir,
yes,
I copied this link you shared, hash /bin and /sh. This total is copy.
Yeah, you have to copy and paste the entire thing. I've copied and pasted the entire thing on the chat window. You have to copy and paste the entire thing.
This one.
Yeah, this one.
Okay, this one.
I think you got the entire thing on the chat window, right?
Okay.
You have to copy and paste the entire thing.
Not here HTTPS US West to AWS.
See, the thing is, whether it's a HTTPS, whether it's a HTTP, you have to copy and paste the entire thing. If you haven't got on the chat window, I'll copy and paste again on the chat window. You have to copy and paste the entire thing, starting from slash, from pound sign to this HTTPS to this one. You have to copy and paste the entire thing. Okay?
Okay.
Rakesh is saying, can you edit the no, Rakesh, we can't do that because we have to define the script once we logic the instance, so that we can't edit the existing instances. Okay? So guys, can I move forward now? Are you all done with this thing? If you say yes, then I'll move forward. Okay, right. So I got the confirmation from Mazhar, and I'm assuming that you guys have. Okay, Shrikant has also said yes. So now I go ahead and click on Add Storage, and you keep the storage settings as it is. Don't change anything as of now. Don't change anything on the step 4. Click on Tag Instance. In the tag instance, you can type in instance A. Okay. So once you just type in tag instance A, you have to go to the next step. That is configure security group. You have to create a new security group right now. So just you can just now take a look at it. I'll keep it 2 minutes to configure the security group. Okay, I'll keep, so you can see what I'm doing in the security group. So I'll name the security group as Apache Web Server S3 security group, and I'll just copy and paste the same thing in my description. All right. Now I would be hosting a small web application, Apache web application of this instance, because that script will enable that. I would use the SSH over port 22 from my IP. I'll add a rule to allow the HTTP and the HTTPS traffic from all the sources. So this is the configuration that you have to do. I'll give it next 2 minutes. Take your time, see this configuration, and apply the same thing from your side. And please, keep a note of the security group in the notepad, because you'll use the same security group while launching a next instance. Because we will launch 2 instances, the second instance would be duplicate to this one, but it would be in a separate AZ. Okay, you're done. All right, so I guess I'm assuming all you're done now, so we can move forward. Right? So now, once we have configured the security group, we click on Review and Launch, and you can review any of the options, but I don't think that you have to review as of now. Click on Launch. Create a new key pair. So I'll just name it as Apache -KP. I guess someone has raised their hand. Yes, Mazhar.
Can you back the window? I was stuck for security.
Mazhar, the thing is, there's a music running in the background. I can't hear you properly.
Yes. I stuck on the configure security group. Can you back the window and I check, see? Because it is, and
This is the one.
yes, wait me.
So let me know when you're done, then I'll move forward. Okay, so I'll just move forward now. Okay, so this is the configure security group settings. Or what I'll do, let me just now take a screenshot of it and send it as a handout. Hang on one second. I'm sending the screenshot of it as a handout to all you guys. I don't think we have the handout option over here. No. Okay. No worries. Okay, so I'll just move forward now. Review and launch. Click on launch. I'll name it as I'll create a new key pair. So you have to select the option create a new key pair. You can keep it name as anything. And please make a note of this one because you will use the same key to launch your next instance. Right? So I create a new key pair and name it as Apache-KP. Right? It will be by default saved in the .pem format. Right? So once I do that, I need to click on download the key pair. Right? Because you have to download this key pair. So most probably this key would be saved in your downloads folder of your PC. So I go back to my downloads folder, and you have to make sure that it is in the .pem format. Right? So I just remove .txt, and I'll just move that on my desktop so that I can use it properly. I'll just keep it as it is in my. Okay, let me just drag that in my documents folder. I'm done now. So now I click on launch instance now, and my instance is launched. So guys, let me know once your first instance is launched so that we can just go ahead and just launch our second instance real quick. So guys, your first instance is launched now. Okay, no worries, Shrikant. If your first instance is launched and it is doing 2x2 checks, it's okay. And let's do one thing. Let's launch another instance, but there will be a difference in the AZ. The configuration would be the same. So you just need to click on launch instance again. Right? In the step 1, you need to choose the Amazon Linux AMI. And just keep the instance type as t2.micro. And just click on configure instance details. Now over here, this time you have to choose the second subnet in the list. Yes, Shrikant, subnet should be different. Choose a second subnet in the list, and once you scroll down, you have to go to advanced details and copy and paste the same script. So I'll just copy and paste the same script. Right? Otherwise, there's no difference. It is just that we have this time we have to choose a separate subnet. You go ahead, click on Add Storage. Keep the storage option as it is. You don't need to change anything. So now you need to click on Tag Instance and just name it as Instance Bay. So I'm just pausing for a few seconds so that you guys can do this step. I guess all people have done this step. Go to Configure Security Group, and this time click on Select an existing security group, and choose the previous security group. So I created this Apache Web Server Security Group. You have to choose the previous security group, right? So you need to select an existing security group, choose a previous one. Once you choose a previous security group, click on Review and Launch. You can review all the options. Right. And once you're done, click on Launch. Choose the existing key pair, the same key pair that we have created while launching our previous instance A. So choose an existing key pair. Choose a key pair that you have created during a previous instance launching. Checkmark this option, I acknowledge. And click on Launch Instance. So we have now two instances launching, instance A and B in different subnets or different AZs. So let me know, guys, when you are done launching the instance. Now you can wait for 2x2 checks. That's not a big deal. So I think it should be done now. So I'm waiting for the confirmation from your side so that I can go ahead and start launching the ELB, or the Elastic Load Balancer. So from Shrikanta, I got the acknowledgement done. Srinivas and Mazhar also done. Okay. So I'm assuming that all you guys have launched these two instances. Now it's time for us to go ahead and click on Load Balancer. Right. Once you go to Load Balancer, you have to click on Create Load Balancer. Now in the Load Balancer, the first thing is you have to type any random name. So I'll just name it as Apache ELB. You can type in any random name of your choice. You have to choose Create LB Insight. Now I'm not sure whether you have created a VPC, but by default there should be only one default VPC. So you have to stick to that. Right, I'm talking about this configuration. Right, Create LB Insight. You have to choose the default VPC within which you have launched your instances. Then you have to keep this option unchecked. Create an internal load balancer. Don't check mark this option because we are creating an internet facing load balancer. So don't check mark this option. Once you do that, check this option, enable advanced VPC configuration. It is mandatory. You have to enable this option, enable advanced VPC configuration. It should be check marked. Right? Now once you check mark this option, you need to scroll down to the bottom. You need to select your subnets within the VPC. So you can see the actions as plus sign. Click on all the plus signs till they become minus, which means that you are adding all the subnets so that the instances in all these subnets should receive the traffic directly from the internet. Right? So I'm just pausing for a few seconds so that you guys can do the step. No, Shrikant, don't add the HTTPS because it will ask for the SSL certificate. Don't add the HTTPS. Okay. Now, once you add the subnets in the load balancer protocol and port, please ensure that at both the sites. Now, I'm just highlighting that so that you don't make this mistake. At both the sites, it should be HTTP over port 80. Please don't choose HTTPS because otherwise you will need then an SSL certificate. You have to choose HTTP over port 80 both at the load balancer protocol and port. Don't use HTTPS in any one of the options. Okay. So I'm just pausing for a few seconds for you guys to accomplish this page. Okay, just give me a few seconds, I'll be right back. Sorry about that. So once you choose this thing, Rakesh is saying, what is the difference between the load balancer cookie settings and application generated cookie settings? Rakesh, the load balancer cookie settings are being generated by the load balancer itself, and the application, which means that during the creation of the application, you may involve the cookie settings during the creation of your application. So whether you want to go with the load balancer's cookie settings or the application cookie settings. So now just go ahead and you click on next assign security groups, right? So you click on create a new security group, and this time in the security group name, you can just type in ELB S3, right? This is for the elastic load balancer security group. Now over here, I'll just copy and paste the same in the description. Now allow the HTTP and the HTTPS traffic from all the sources. That's it. You're allowing the inbound traffic from all the sources. So you have to create a new security group for the load balancer and allow the HTTP and the HTTPS traffic from all the sources. It should be anywhere. Just take your time and just pausing for a few seconds. I guess Masood is raising hand. Yes, Masood.
Sir, in source we can select my IP, custom IP.
See, in the load balancer you have to select from all the IPs anywhere, because the load balancer will receive the traffic from the internet. So the source should be anywhere.
Okay, anywhere. Okay.
Yeah.
Thank you.
Thank you. So now, once you select your, so once you select your security groups, click on configure security settings, skip this option, skip the step 3, go to configure health check. So now, once you skip the third step, you come to the fourth one. In the fourth step, you don't have to you don't need to change anything except in the ping path, just keep a /. That's it. I repeat, in the fourth step, you don't need to change anything. It is just that the ping path should be a /. I'm pausing for a few seconds so that you can do the step. Because this Apache PHP application that we're running, we will be the default web page will be /. Okay, Kalyan, you want to see the previous step? In the previous step, you have to allow the HTTP and the HTTPS traffic from all the sources. So you have to choose the source as anywhere. So once you create a security group, you define the name and the description. Allow the HTTP and the HTTPS traffic from anywhere, from all the sources. Okay. So once you define that, in the fourth step, please ensure in the ping path it is a /. You have to skip the step 3. Go to fourth step. Please ensure that the ping path is a /. Except that you don't need to change anything. Keep all the things as it is. Only the ping path should be a /. That's it. Otherwise, there should be not even a single change. Now, once you do that, you need to click on Add Instances. Choose both instances. I think. Why my instances are not showing up? I think I didn't, while explaining you, I didn't choose my, hang on one second. Just give me 1 second, I need to check why my instances are not showing up. I need to cancel out. Let me just create the ALB again. Hang on 1 second. Just over here. Okay, select the security group. I need to check why my instances are not showing up. Otherwise, they should show up over here. There's something wrong at the back end. Otherwise, you guys have to select both the instances that you might have selected while we have launched our previous instances. Okay, so you have to. I think I might have to. Give me 1 second. I need to check how many VPCs I have in my. Sounds weird. I have only one VPC still is not showing up. Okay, anyways, you have to select the instances that you have launched before, and you click on Add Tags. In the sixth step, skip the step, click on Review and Create. You can review any one of the options if you want, right? I'm not sure why the instance is not showing up from my side. Anyways, once you review all the options, hit on Create, and your load balancer will be created. Right. So the load balancers will be created. Your instances after a few seconds will show up as in service. Okay. In the meantime, I'm launching another load balancer real quick. So it will take for some time for you for this load balancer to show up. That's weird. Why is it's not showing up over here? Anyways, so you got the point that we launched the two instances using the script. You have to choose those instances and launch the load balancer. Now, once this load balancer is created, it will take a while for the load balancer to show the instances and in service. Once it is in service, it is time for us to go ahead and test the functionality of the instance of the load balancer. How you can test the functionality? Once your instances are showing us in service, right? You have to copy and paste the DNS name of your ELB, and you need to check out this, copy and paste it in your web browser, and it will show up the Apache web page or the web application that we just launched, right? So once you refresh the page, the load balancer will route your traffic to different instances and different AZs. It will take around 2 to 3 minutes for your instances to show up as in service. Okay. So I guess all we guys have launched our ELB now. Just in case we are stuck somewhere, please let me know. Okay, Mazhar has a question. Yes, Mazhar, what's your question?
Sir, my all process is completed 15 add EC2 instance, and there instance A and instance B, and running. Now, what can I do to add tags? Next step is add tags.
Add text? No, and you have launched a load balancer. No, so the thing is, this thing we have done before launching a load balancer, right? So your load balancer has not been launched right yet.
No, I should cancel this page, add EC2 instance.
Now, why you cancel it?
There is 5 steps, add EC2 instance. Or I'm running instance A and instance B. But how can I check the load balancer from side?
How can you check both the?
Check the load balancer. How can I see the load
Have you
balancer?
launched the? Okay, in the load balancer, if you go over there, so you have launched load balancer now.
Yeah.
So under the load balancer, once you go over there, under the instances, you will have both the instances showing up. From my perspective, instance B is not there. Then choose that. So once you go to the load balancer, under the instances, your instance should show up in service after some time.
Okay.
This is where you can check it.
There is 5-6 review, add tags review command into define load balancer. Step 5, 6, 7. Can you go back to your create load balancer?
Now, I've already shown the step, Mazhar. I've already shown the step.
I showed the step, but after review, we can add tags. Create tag, they will set.
Add tags, you can skip the step. Add tags, you can skip the step.
And
move forward.
Also?
Yeah. In the review, click on review. Yeah.
Yeah, and then there is our previous and create.
create. That's it. Your load balancer has been created.
Okay.
All right.
Thank you.
Thank you. So now your load balancer has been created. So what you guys, once your instance show up in service, what you need to do is you need to copy and paste the DNS name of your load balancer. Don't include a record. Please don't include that. Just copy and paste this DNS name in your web browser and paste it over here. And once you refresh this, the DNS name, it will start showing up your web application that we have launched. Okay, and I guess it is being done now from all your site. So someone has already done that. It is in service. Okay, so Kalyan, you have to copy and paste the DNS name. And Srinivas, if your instance are showing in service, could you please copy and paste the DNS name on the question pane? I'll test it from my end. So Srinivas and Kalyan, please, you can also copy and paste the DNS name in your browser, and also alternatively, please ping it to me on the question pane. I'll test it from my end as well. Okay, so Srinivas has given his DNS name. So I'll just test the Srinivas the load balancer. I'll just copy and paste the DNS name, and it is up and running. You can see that it is showing as US West 1B, right? If I refresh this page, it will take me to another. I think here, Srinivas, you have launched 2 instances in the same. Okay, 1A and 1B. So it is showing me to the 1A now. And if I refresh this page, it may take me to the 1B. So Srinivas, your practical has been accomplished successfully. Congratulations. And I'm taking the Kalyan's ELB. So Kalyan, I'm just copying and pasting your ELB DNS name. And I'm going to the US West 2A instance. Refresh this page. And I'm going to the second instance, I guess, in the same easy. Okay, 2-way now. So I'm going to us. So once I refresh this page again, most probably it takes me to some another instance in the another easy. Okay, so this is how you can test it, which means that this gives you an idea. It's a prototype that how the load balancer works. Okay, so that's it. So Mazhar, I would appreciate that. That please, you can send me your load balancer's DNS name. Okay. And Srikanth, you have created the load balancer. You can give me your DNS name if you have. So I guess, guys, you got the thing now. You can adjust all the settings of the instance and the load balancer that we have done so far, and this is how you will accomplish the design. This is a small prototype. You may have a big architecture, and this is how you route the traffic towards the load balancer, which will eventually be routed over towards different instances. So Mazhar, I'm just taking your load balancer's name. Okay, so I'm getting to one of the instances in 1A. If I refresh the page, I'm getting to another instance in 1B. Good job done. All right, so that's it. So Srikanth, this has been created in North Virginia. It's okay, Srikanth. You can create it anywhere. It doesn't matter. Okay, so I guess you got the point now. I think you guys might have gained more confidence by doing by yourself. So that's it. This completes our entire elastic load balancer. All right. I hope that you enjoyed this exercise. So let's do one thing. Let's take a break of 15 minutes. Okay. You can just take your dinner break, or you refresh yourself. Let's take a break of 15 minutes. Please be back, and we'll start with our auto scaling. It will be much more interesting as compared to ELB. Okay. Shrikant, if your instance is showing out of service, you have to perform some troubleshooting. Please ensure that if the instance is showing still out of service, you have to go to the health check monitoring, and please ensure that the ping path is a /. If it is / index.html, it will not work. Now, Shrikant, the region doesn't matter. The region doesn't matter over here. Okay. Another troubleshooting step is that if your instances are still showing out of service after some time, you can remove from the load balancer like this. I'm doing that right now. And it's a kind of a glitch that I've seen that. And click on edit instances and select your now my instances are showing up, right? And select your instances again, and they will show in service after a few seconds. Or still, if it doesn't work, restart your instance. Now you can see that my instances are in service now. If I just copy and paste, then I should be able to see my load balancer that it's working successfully now. So mine is also working now. So you can see if I refresh this page, I'm on 1B. If I refresh this page, I will be on 1C after some time. Okay? So mission accomplished. All right, guys. So let's take a break for 15 minutes. Please be back, and we'll continue with our conversation. All right? Thank you. Welcome back. I guess all people are back now. Okay. So we have done with the load balancer. We'll just go ahead and start with our next topic, that is auto scaling. So now I just explained the theory of it, and after that we'll see the practical side of the auto scaling. Now, what is an auto scaling? An auto scaling means that you can modify your architecture whenever it is required. Right? Now, it is based upon the principle of elasticity. Now, if you remember, we have discussed the principle of elasticity, where we can increase or decrease our number of instances, or we can grow or shrink our architecture whenever it is required. And this can be based upon different factors like time of day, patterns of the incoming traffic, and demand. Right? So the elasticity is a principle. And auto scaling is the practical application of it. Using this auto scaling, you can anytime increase or decrease the number of instances depending upon the threshold values that you have defined. So within the auto scaling, we use a CloudWatch and different kind of components to make it successful or automate our infrastructure depending upon the thresholds that we define going forward. Now, in the auto scaling, we have something called auto scaling groups. What is an auto scaling group? An auto scaling group is a logical collection of identical EC2 instances. Now you group your web servers depending upon their functionalities, their behavior, the application services they're running upon them, right? You also define something called policies. See, the thing is that the policies are the real engines that will drive your auto scaling groups. Using the policies, you define that what are the events that should help you or help the auto scaling determine to increase the number of instances in a group or decrease them. What are the benefits you get out of the auto scaling? First thing first, it tends to make your design more fault tolerant. For example, if you see this diagram right in front of you on this PPT slide, let us take this US West region, California. I'm sorry, give me 1 second. So let's pick this one, US West region, North California, where you can see I'm marking this with a green pen. You have, let's suppose, in the availability zone A, today you decide that, okay, I should have 4 instances that should be up and running. And also, you eventually you also run 4 more instances in AZB. So 4 plus 4 is equal to 8. Now, let's suppose due to some kind of event, the entire AZA goes down. What will happen eventually in this case is that if your AZA goes down, the auto scaling will automatically, so which means that these 4 instances will go down. So the auto scaling will automatically launch 4 more instances to compensate and make your capacity to 8 again. So apart from making your design more fault tolerant, the auto scaling also ensures that you have the right capacity of the instances running. So in case of any kind of failure or the instance failure or the AZ failure, it will automatically launch the duplicate instances in different AZs or in the same AZ depending upon what kind of failure it is, and it always ensures that your architecture has the right capacity, which means that your architecture or your design or your network has the right amount of instances that you want to be up and running at all the times. Okay. Apart from ensuring that your design is more fault tolerant, it has the right capacity of instances, it also ensures that your application is more highly available, which is quite mandatory, right? So these are three main benefits of the auto-scaling. So auto-scaling, if it sees that if the instance fails or the AZ fails, it launches the instances in the same AZ or a different AZ to compensate for the loss that has already occurred. Okay. We'll skip this slide. I'll discuss that in the next one. Now, what are the components of auto-scaling? The first component of the auto-scaling is called the groups. What is a group? A group is a logical collection of identical instances, right? So you group your instances together. For example, you may have 10 instances in a group that have the same set of application services running upon them, right? Launch configurations. Now this is quite important. This launch configuration, it is nothing but these are the templates. These are nothing but the templates. These are not resources that you run in your architecture, but these are the templates. Now you might be wondering, why on the earth I need templates in the auto-scaling group? See, we need the templates because if the auto-scaling, if it wants to launch the instances in the future going forward. Now, in the previous slide, I showed you an example that if your 4 instances fails, in that case, the auto-scaling will launch 4 duplicate instances to compensate for the loss. Now, the question is how the auto-scaling will get to know that what should be the exact configuration of the instances that it should launch. The configuration that it will put from the template is called launch configuration. Using this template called launch configurations, the auto-scaling will get to know, for example, let's suppose this is a launch configuration, this is a template. So in the template define, okay, this is my instance ID, this is my AMI ID, this is my security group, this is my key pair, right? This is the script that I want to install. In the entire launch configuration, it's a template. In the template, you define that what should be the exact configuration of the instances that would be launched through the auto-scaling in the future going forward. Using the template, the auto-scaling get to know the exact configuration of instances, and based upon the exact configuration, it launches the duplicate instances on your behalf automatically. Right? Next, we have something called scaling plan. See, the thing is that if you want to do something, if you want to accomplish a higher goal, you have some plan out of it, right? If you don't have any foolproof plan, the chances are that that thing that you're trying to accomplish may fail. Scaling plan means that we create a foolproof plan, right, to facilitate or to ensure that the configuration that we're defining with the auto-scaling group, it works successfully. Which means that in the scaling plan, I decide or I determine that when should I scale up or scale down my architecture. What are the thresholds that are there? It can be a high CPU utilization, might be a low CPU utilization, might be a high amount of traffic, low amount of traffic, any event. Might be it's a time of day. For example, during the Christmas Eve, you want the number of instances to increase, but as the Christmas Eve goes away, you want the number of instances to decrease. So everything you put in the scaling plan, you have the entire plan that how this automation should work on your behalf. Okay, so these are the 3 components of the auto scaling that will just go ahead and configure step by step from scratch. Let's move forward. Now I'll discuss the auto scaling basic life cycle. where I will show you that how exactly the auto-scaling works, because till this point of time we have seen the terminologies, groups, policies, plans, launch configuration, but how they come and fit together. So let's see and discuss the auto-scaling basic life cycle. Now, in the first step over here, so it's a flow chart that I will show you right now. In the first step, you have something called auto-scaling group. What is an auto-scaling group? It's a logical collection of identical EC2 instances. Now, in this auto-scaling group over here, I have two instances. You can see that there are two boxes showing up over here. These are the two boxes. So I have two instances running in the auto-scaling group. These two instances are identical in nature. They have the same set of application services running upon them. Plain and simple. An auto-scaling group is a logical collection of identical EC2 instances. So in this auto-scaling group, I have two instances that are identical in nature. Now, you want to trigger an event so that the number of instances in this group should increase. So what happens is that you use a CloudWatch or use a scale-based event, a schedule-based event to trigger a scale-out event. Now you have to make a note of this thing, this scale-out event, whatever exactly means, what exactly this means. If I say scale-out, so I'm just making you comfortable with the terminologies that we'll discuss going forward. Scale out means that you want to increase in your number of instances, right? And if I'm saying scale in means that I want to eventually decrease the number of instances, right? So you have to make the note of these two things, because I'll frequently say scale out, scale in, so you should be very much aware of what exactly I'm talking about. Scale out means I'm expanding my architecture, I'm increasing my number of instances. Scaling means I'm shrinking it, I'm decreasing my number of instances, right? So what happens over here is that using the CloudWatch, now you will use the CloudWatch in a very efficient and accurate manner so that it triggers the event, or it can be a schedule-based event, which means that during certain time of day you need more instances. So it triggers a scale-out event, which means that now there's an event which will increase your number of instances. As this scale-out event occurs, an extra instance is launched. An extra instance or additional instance is launched. This additional instance, this one, has the same exact configuration which it has acquired from the launch configuration. So this instance will be duplicated to this one. It will have the same set of application services running upon that. So we have two instances over here. This extra instance is launched. As soon as this extra instance is launched, this is appended to your auto-scaling group, right? Which means that now previously I had two instances, now I have three. From two, now I have three instances. Just give me a second over here. Right? So now from two to I have three instances. Now, so this is the first part of the story. This means that I'm accomplishing a scale-out event to increase my number of instances to cater to my requirement. Now comes a second part of the story, in which I need to decrease back the instances. So a scale-in event occurs now. So in the scale-in event, another alarm is generated. So after a few hours or after a few days, you have put a threshold that, okay, now a scale in event should trigger. That can be triggered by the CloudWatch or by the schedule-based event. As soon as it is done, your extra instance has been removed now. So previously you have 2, then you have 3, now you're back to 2 now. The extra instance is being removed, and now that instance is terminated. So you're back to normal. Above one is sorry. So the above one is a scale out procedure, whereas this one is a scale in. This is how it works, right? You have the auto scaling group. It's a logical collection of identical instances. A scale out or scale event triggers from the CloudWatch or schedule based event that eventually decides that when should the instance should be increased or decreased from your auto scaling group. So this is the auto scaling basic life cycle. Now this is the essence of it. If you didn't understand this thing, it would be very hard for us to digest the auto scaling concepts going forward. So if you have any questions, please let me know. I'm pausing for a few seconds and waiting for your questions. I guess no questions, right? All right, so I'll just move forward now. I guess we have a question. And Kalyan is saying, does it increase only one instance or it is based on the template? Kalyan, it can increase more instances. This is just an example that I gave you. You can add more instances depending upon how many instances you want. And the number of instances are not being decided by the templates. In the templates, we only decide the configuration of the instances. The number of instances are being defined through the policies and plans. All right. So let's move forward now. Let me just drop it out. Okay. So you have to keep one thing in mind. An auto scaling is being restricted to a region, which means an auto scaling will span across your instances in different AZs within a region. An auto scaling will never span across different regions, right? Instance distribution and balance across multiple zones. This is quite important. See, the default behavior, the default nature of the auto scaling is that it tries to maintain the balance across all the AZs. If I'm saying that, which means that it ensures, or it tries to ensure, that all the instances, all the AZs have equal number of instances. It tries to ensure that all the AZs have equal or similar number of instances. Multi-zone instance counts when approaching capacity, so you define the capacity. So as you add more zones instances, so it keeps a track on it. All right. So this ends our theoretical overview of the auto scanning. Rakesh is saying, can't we make our own AMI and use it for the auto scaling? Of course, Rakesh, you will create your own AMI. In an ideal situation, you will have your own AMI that you will apply to the template. Right? I'll show you the procedure how to create your own AMI once we discuss the concept of EPS. We'll cover that. Okay. So this covers our auto scaling, the theoretical overview. Any questions, any doubts before I can just jump over to the practical side of it? Let me stop these instances as of now, because we don't need that. Any questions, any doubts, please feel free to let me know so I can just move over to the auto scaling. Now, once we do the practical side of the auto scaling, we'll incorporate both the load balancer and auto scaling to work hand in hand. So it's a quite interesting thing. We'll see that how it will work. All right, so let's kick on. And the auto scaling can be tracked under the load balancers, right? So where you have the load balancers, you have the auto scaling and the launch configuration. I go to launch configuration first. Now I already have a launch configuration created, so let me just remove that. I'll start from scratch. So what is a launch configuration? A launch configuration is nothing but a template. That's it. It's not a resource. So you go to launch configuration, click on create launch configuration, and we will see the same steps. It will be the same steps. There will be no difference. It will be the exactly same steps that we follow along the instance creation. But you have to mind one thing. We are not launching an instance right now. We are creating a launch configuration. It is just a template. That's it. Now, for our example, I'll choose the Amazon Linux AMI. But in a real-time practical scenario, you will use your own AMIs. So it's the same thing that was raised by Rakesh. I'll show you how you can create your own AMIs. In the real-time scenario, you will use your own custom-built AMIs to be applied in the launch configuration. That will have exactly the same kind of services and applications that you want to run, right? Now over here, for this example, I will choose a public AMI, not a custom AMI. So I'll go with the Amazon Linux AMI. Now the steps are the same as we have in the instance creation, but this is just a template called launch configuration we are creating. I choose a td.micro as my instance type, configure details. I'll just name it as test. LG stand for launch configuration. I'll not select anything. Let's do one thing. In the user data, I'll just copy and paste the same script. Right. And I click on add storage. I'll keep the storage options as it is. Configure security group. So the thing that we're doing right now is we are creating a template. That's it. Review, and we can just click on create launch configuration at the bottom right corner. So it is just a template that we have created, and we choose the key pair, and we click on create launch configuration, and this creates our template, right? So that's it. I guess we have a question right now from Mozar. Yes, Mozar, I'll put you on the mute. What's your question?
Sir, can you repeat these steps? Use AMI for exercise.
You mean to say, can you repeat the steps? Means that can you perform the?
Yes,
Now,
sir.
you want to repeat the steps or what?
The previous steps for exercise, sir.
Mazhar, I'm getting high background noise from your side. You can type the question.
Sir,
Put you on the because the background noise coming from your side.
can you?
Mazhar, I've put you on the mute because I was getting a background noise. Please type the question. Right. Now, so, okay, Mazhar has typed the question. Sorry, Mazhar, I was getting. Mazhar, you want me to repeat the steps? These are the same steps as we do in the ELB, in the instance creation. Mazhar, please see the recording because repeating the same steps becomes tougher for me. Right? Please see the recording just in case if you haven't seen the steps. The same steps are the same as we create the instance. There's nothing special about it. Now, I'll just go ahead and create an auto-scaling from this launch configuration. So this is just a template that I've just created. I click on create an auto-scaling group. And now I will be applying this launch configuration on this group name on the auto-scaling group that I have just created. I'm about to create right now. So I just name it as test ASG. ASG stands for auto-scaling group. So I'm applying this launch configuration on this group name. Right? Now, this is quite important. This one. Group size. What is that? Group size means this group size. Now, please make a note of it because this is quite an important concept. Group size means this is my desired capacity. This is the desired capacity. This means that how many instances I want to be up and running in my architecture at all the times. Desired capacity means that the auto-scaling should ensure that the number of instances that I've defined, it should not go below that. Desired capacity means these many instances should be up and running at all the times. So there should be no compromise on that one. So over here, using the desired capacity, I define the number of instances by defining the group size. So what I will do, I'll just type in 2, which means that I need 2 instances to be up and running in my auto-scaling group. There should be no compromise on that one. Now here comes the VPC. Now what happens is the auto-scaling works in the confinement of region. So you have to choose the virtual private cloud, and you have to choose the different subnets across which the auto-scaling group will launch your instances. Right. Now comes the advanced details. Now comes the real action. Under here or over here, you can check mark this option, receive the traffic from the load balancer, and select the load balancer that we have just created before we started with our auto scaling. What is that? Why we need to involve the load balancer? Let's take a situation. Let's suppose that today, now for example, let's suppose that this is your VPC. This is a virtual private cloud that you're creating, right? Now you have these 2 different subnets. This is subnet A that is associated with my AZA, and this is my subnet B associated with my AZB. You have a load balancer. This is my LB load balancer, and there's one single instance in AZA, another single instance in AZB. Now, these two subnets are the part of my auto-scaling group ASG. Right. These two subnets are the part of my auto-scaling group. Now the user is sending the traffic to the load balancer, and the load balancer is further dividing the traffic to the instances. Now what happens is that, let's suppose this instance goes down, or the entire AZ goes down, let's suppose. In that case, this auto-scaling group will come into action, and it will launch a duplicate instance in another subnet. Now, how can I instruct this load balancer that, hey load balancer, a new instance has been launched from this auto-scaling group, please send the traffic to it? Because a load balancer will not have any intelligence, I have to configure in such a way that if the auto-scaling group launches new instances in the future going forward, the load balancer should be aware of that kind of thing. All right. So in order to facilitate this kind of thing, this kind of functionality, I checkmark this option, receive the traffic from the ELB, so that this auto-scaling group, now this auto-scaling group contains different subnets, and it will have instances within that. I'm saying that this auto-scaling group, or the instances in this auto-scaling group, they're bounded, or they're intended to receive the traffic from the load balancer. So if I increase more instances in the future going forward, it is responsibility of the load balancer to send the traffic to the newly launched instances in case a scale-out event triggers. So this is where I define that thing. Health check type, I choose load balancer. I can choose EC2 if I rely upon CloudWatch statistics. But in an ideal situation, it is always recommended that if you're choosing the load balancer, then you choose the health check type as ELB. Right? Now this is quite important. This one. Health check grace period of 300 seconds. This one. What does this mean? Health check grace period of 300 seconds. What exactly this means? See, what happens is, for example, in our previous example, if you can recall, the load balancer sends the health check to instances after each 30 seconds. Fine. Now, let's suppose that this is your VPC, and this is the subnet. This is the load balancer, and there's a one instance over here, and the load balancer is sending the traffic to it. Now this subnet is a part of the auto-scaling group. Now due to some kind of event trigger, a new instance is being launched. It launches a new instance over here. Right. Now it is quite logical that I think it makes sense that whenever you launch any instance, it takes around 2 to 3 minutes or 3 to 4 minutes to show you 2x2 checks. I guess you agree with me. So if an instance gets 2x2 checks, which means that all the necessary scripts and the softwares have been installed, and the instance is now ready to receive the traffic. Now the problem is that this instance will take its own sweet time to install all these softwares, services, operating system, applications, scripts, everything. It will take 3 to 4 minutes of time. But this load balancer is not aware that, okay, what's the behavior of the instance, and because of its default behavior, after each 30 seconds it will start performing the health check traffic, or it will send the health check traffic to it. And quite obvious, after 2 thresholds, since this instance is still in booting state, it will say, okay, instance, I'm not getting a response from you. You are unhealthy. So there would be a kind of a chaos or confusion where a load balancer is not aware that an instance is just launched, it is booting up. And during the booting procedure, it is quite obvious that the instance will not respond to the health checks that are being provided by the load balancer, or that are being shooted by the load balancer. So since the instance, while booting up, it is not in a situation to respond to the health check queries performed by the load balancer will fail the health check and will stop sending the traffic to it. So this is the confusion or chaos that will happen. Therefore, we configure the health check grace period of 300 seconds, which is 5 minutes. We instruct the load balancer and say, hey, load balancer, once the newly instance gets launched, have some patience and don't perform the health check in next 300 seconds. Which means I'm giving enough room, I'm giving enough time to the newly launched instance to boot up within 5 minutes. And after 5 minutes, if it is up and running and it is getting 2 by 2 checks within 300 seconds, then the load balancer has the quite independence to perform the health check. But before the 300 seconds, the load balancer will never send the health check message to the instance. So I'm giving a room, or I'm giving a privilege of 300 seconds to the instance, to the newly launched instance to boot up, so that after that the load balancer can start sending the health check to it, and there will be a genuine health check stats that would show up now. Right? I guess you guys agree with me. So you have to define now, depending upon how much. So the thing is that whenever you have your own AMI, you will perform this kind of testing, and you have to calculate that how much time your instance takes. So whenever you choose your own AMI to boot up your instance and you install all the scripts and applications, eventually how much time your instance takes to show up 2 by 2 checks. Might be it takes more than 300 seconds, then you can increase to, like, let's suppose 600 seconds. Might be it takes less time, you can just define to 100 seconds, depending upon how much time normally your instance takes. But by default, we take it as 300 seconds. So this is called the health check grace period. Next, we have something called instance protection. This is a new feature that they've added in. You can protect from scaling, which means that you can protect your newly launched instances to be terminated. If any scaling event triggers, your newly launched instances would never be terminated. Now we can also enable this option later on, so we'll just skip this step. That's about the first page of the auto scaling group. Any questions, any doubts so far? I'm pausing for a few seconds and waiting for your questions. No questions as of now, right? So we can move forward now. So now we need to click on next configure scaling policies. Now over here, I can select this one, keep this group as its initial size. What does this mean? This means that I can keep the group as its initial size, and if you can recall, we have chosen the group size as 2. So if I choose keep this group as initial size, I'm instructing the auto scaling group saying, hey auto scaling group, we have to have 2 number of instances at all the times. It is your responsibility that I have the right capacity of the 2 instances to be up and running at all the times. Don't go below 2. So using this, keep this group as initial size, it will get this instruction. Right? So this is the first kind of simplest scaling plan that you'll be creating. I guess we have a question from Mazhar. Yes, Mazhar, what's your question?
Sir, in your create auto scaling group, what we can give the group name? They ask the group name.
You can type anything.
Anything?
Yeah.
Okay.
It's just a name that you have to type in. That's it.
Okay. Thank
Right?
you.
Thanks. All right, so let's move forward now. So we'll give the group ads as initial size. If you want to go into a detailed level of capacity provisioning, we'll use scaling policy to adjust the capacity of this group. Now this is where the real action begins. Please pay attention, because this is now you have to define the policies. Quite important. Please pay attention, because I don't want that I have to repeat myself multiple times, because this is quite an important concept. Scaling policies means that now you have to define that what are the thresholds that should eventually decide the scale out and the scale in events in your architecture. First thing first, I'll define the minimum and the maximum size of my architecture. So I'll say minimum is 2, maximum is 10. So over here, I'm defining 2 and 10. These will be the minimum and the maximum size of my group. So it should never go below 2. It should and the number of instances will never go beyond 10. I define a fleet size. Now comes the defining of the policies. Increasing the group size means that this entire thing is for the scale out event. The policy that I'm going to be defining would be for the scale out. If I just scroll down, this decreasing the group size, this would be for the scale in. Right? So I have to define 2 policies for the scale out and scale in. These are the 2 policies that I will be defining over here right now. Now I'll just click on create a simple per scaling policy and create a scale out policy first. In this simple policy, I'll define when should I increase the group size. So for that one, I'll just create a new alarm. I will just click on this one, add a new alarm. Now I should start defining the alarms that should trigger the events to perform the scale out procedures or scale out things in my architecture. First thing first, I would be creating an SNS topic, simple notification service topic. I click over here and I can type in anything. Auto scaling topic. Right? Now over here I will be defining the email address so that I can define that if any kind of event triggers or if this alarm triggers, who should receive the email. So I'll just type in my email address. Right. Once I type in my email address, now it's time for me to define the alarms. I can select average, minimum, maximum, sum, sample count, and I can choose a matrix depending upon I want the alarm to be generated. It can be CPU utilization, discrete operations, discrete operations, network in, network out. Right. So for example, I choose CPU utilization, the average one, which means it will calculate the average CPU utilization of all the instances in my architecture. I'm saying that if the CPU utilization, so I can see, I can define the values greater than, equal to, less than, equal to, whatever I want. I'm saying that if the average CPU utilization is greater than or equal to 80%, and this happens for one consecutive period of 5 minutes, 15 minutes, 1 hour, 6 hours, 1 minute, whatever you want, I choose as one consecutive period of 5 minutes. And this is the name of the alarm that will be created. So I repeat, in the alarm creation, I define a topic name. I define the email address so that this will receive the email when this alarm is being generated. And I'm saying if the average CPU utilization of this entire architecture, it goes more than, less than, equal to, or less than or more than 80% for one consecutive period of 5 minutes, then this alarm will be created or generated. So I click on create alarm now. Right? And once I say that, okay, this alarm has been created or generated, I want some action to happen because this is just an alarm. But based upon this alarm, I want to define that, okay, if this alarm has been created or generated, what should happen? Now, for this alarm, I should receive a notification topic. For confirmation, let me just open my Gmail. Hang on 1 second, please. Give me 1 second. Okay, I think, okay, it's not in the mail right now. So now I need to go ahead and I need to define the actions now. So I'm saying that if this kind of thing triggers, if the average CPU utilization of my instance is more than 80% of the entire architecture, then please add 8 more instances. Till this point of time, since I've mentioned 2 instances as the minimum, which in the desired capacity is 2 instances, I'm adding 8 more instances so that it reaches the capacity of 10. 2 plus 8, 10. So I'm saying, please add 8 more instances if this kind of event triggers. Right? And it says, and then wait by default 300 seconds before allowing any of the scaling activity. Now this is quite important. This is called the default cooldown period. This one. This is called the cooldown period. By default, it is 300 seconds. Cooldown period, and by default, it is 300 seconds. What exactly it means? See, what I'm saying is that I want the 300 seconds. I want that once the scale out event triggers, there should be a weightage or a stoppage of 300 seconds before resuming any scaling activity. Because what happened is that during the time when the instances are launched, now for example, after this alarm is triggered, it will launch 8 instances. Now these 8 instances will take their own sweet time to boot up, install the scripts before they can get 2x2 checks. During that time, the CPU, the CloudWatch will say that the CPU utilization is still high, and it will trigger more events to trigger more instances. To avoid this situation, I'm instructing that CloudWatch have some patience. Once you launch the 8 instances, wait for 300 seconds before you can play or you can start triggering any of the scaling activity. So that's called the default cooldown period, where I'm giving enough room or the time for the newly launched instances to boot up, get 2x2 checks, and be up and running. After that, the CloudWatch can trigger more alarms to add or subtract more instances if required. So this is called the simple scaling policy to increase my group size. Right? I can also do it with steps. Instead of adding all the instances in one go, I can click on create simple scaling policy with steps. Over here, I can define, okay, add 2 more instances if the average CPU utilization is between, let's suppose, 30 to 40. Add 2 more instances if it is between 40 to 50. Add 2 more instances if it is between 50 to 80. Add 2 more instances if it goes beyond 80. And after each step, there should be a weightage of 300 seconds, so that I give enough room for the newly launched instances to boot up before triggering any other event. So instead of adding, I'm sorry, this should be 2. So instead of adding all the 8 instances in one shot, I'm dividing. I'm saying that I will add these. So 2 plus 2 plus 2 plus 2 plus 2, 8. So I'm adding all the instances in multiple steps. So this is called the step scaling policy. And after each step, there would be a weightage of there would be a period of 300 seconds by default, so that once the newly launched instance after each step they are up and running, then I can resume any other scaling activity. So this is called the warm up. I'm saying that you should warm up after each step. So this is how I define my scaling policy. Likewise, I can also do that with my decreasing group size. Any questions so far regarding this policy creation? Any question, any doubt? I'm just pausing for a few seconds, and please let me know if you have any questions. I think we don't have any questions right now, and the same thing we can decrease the group size. I can say I can add a new alarm. I will choose the same topic. So where is the topic right now? Okay, let me just select this one topic. So I'm saying now if the I'm doing for the scale in event now. So I'm saying if the average CPU utilization goes between or below 30% for one consecutive period of 5 minutes, I create a new alarm, and in that case I'll say remove all the 8 instances. And also I can create the I'm sorry, this is a step scaling policy. So I'm saying remove all the instances if the CPU utilization is less than equal to 30% of all the instances as an average. Shrikant is saying if the minimum group mentioned in the top and minimum max group size, whether it will be throw an error. If the minimum group mentioned the top, minimum, maximum group, and it is less than the group size. Shrikant, if you have defined the minimum group, if you have defined the minimum and the maximum group size, it will not go beyond that or below that. It will not throw any error, but it will not launch less than 2 instances and more than 10 instances. So my 2 instances are already running. I'm saying I'm adding 8 more instances if my CPU utilization is more than 80%, and I'm removing those 8 instances if the CPU utilization goes less than 30%. Okay. Yeah, less than. It is less than. If the average CPU utilization of my entire architecture goes below 30%, then it is intended to remove all the 8 instances. So this is how I define my scaling policies. All right. Srinivas is saying, but you may know whether you have 8 instances or not. Srinivas, the thing is that we can generate the alarms or trigger the alarms. Once we move forward, we can trigger the alarms once the extra 8 instances are launched. We'll get a notification over the email that okay, this thing has been done. I'll show you those kind of notifications. So Srinivas is saying, so you mean the scaling will occur only after the peak scaling out? Srinivas, the scaling event will occur after the CPU utilization is less than 30%. So these two scaling policies are completely different from each other. Okay, so regardless of the fact what I've defined in the scale out and scale in event, these two different policies will act independently. The above one will say if the CPU utilization is more than 80%, I need to add 8 instances. If it goes below 30%, I need to remove the 8 instances. They will work independent with respect to each other. From each other, I would say that. Okay. So what I would do is I'll keep it as simple because I can't simulate the high CPU utilization as of now. So I'll just keep the group as initial size, where I'm instructing that hey load balancer, hey auto scaling group, please ensure that my group size is 2. Don't go below that. Okay. So I keep it simple as of now. Click on the next configure notifications. Click on add notification. I can choose SNS topic. And I can say that if any one of this event triggers, whether the instance is launched, terminated, failed to launch, failed to terminate, please send a notification to me. I can add multiple notifications so that multiple people are being notified. Okay, so now I click on next configure tags. I can review this tab, review. I can review everything and just click on create auto scaling group. So now my auto scaling group has been created. Let's wait. So my auto scaling group has been created. I go to view auto scaling groups, and now what will happen is that if I go to this auto scaling group has been created, right? I go to instances, and I would be seeing 2 duplicate instances to be running because my desired capacity is 2, and you can see this instance and this instance is up and running. I'll just name it as first. First instance, and I'll name it as my second instance. Right. First instance, second instance. Now they're initializing this first instance and second instance. They're automatically booting up because I've defined the auto scaling group. And if I go to load balancer, they will automatically report to it. So right now this one, first instance and second instance. What is that? I just go to load balancer and let me remove the previous instances. And you can see that since I have involved the auto scaling group to work hand in hand with the load balancer, these instances are reporting automatically, and they're showing in service with my load balancer. And if I just copy and paste the DNS name, I just copy it and I paste it over here, the load balancer will show up my web application. But this is not what we want to achieve right now, because this we have already seen the load balancer, how it works. Now before I can just go ahead, I just confirm the subscription now, because I just received the email so that I can receive the emails for this SNS topic. I would be subscription confirmed. Now let's do a real action right now. as this load balancer is working hand in hand with my auto scaling group. So if I just go to the auto scaling group now, so you can see the entire thing over here, the entire thing. You can see the log files that, okay, this has launched my instances, and I can see the all logs over here. Let's do one thing. Let's go ahead and terminate one of the instances manually and see whether the auto scaling group launches an extra instance and the load balancer starts sending the traffic to it or not. So I'm just waiting for these instances to show 2x2 checks. It is already doing that. I'll go ahead, go to my first instance and go to actions and terminate it and see what happens. My first instance is terminated now, that I've done intentionally. And now if I just go to the load balancer, check the instance. That first instance is gone now. I go to auto scaling now and see what it has observed as of now, and you can see that it is showing this first instance as unhealthy. This one, if you can see over here, it is showing as unhealthy. Right now, in an ideal situation, since my desired capacity is 2, and I've already terminated one of the instances, the auto scaling group should launch an extra instance to compensate for the loss that I've done intentionally. I go to the instances now, and let's wait for a few seconds and see if the auto scaling group comes to the action and launch an extra instance real quick. Let's see. Here we go. And you can see this, it has started launching a new instance, this one. And let's name it as third instance now. So you can see the beauty of the auto scaling. Without the manual intervention, it launched a duplicate instance. A duplicate instance, yes. Using the launch configuration, it launched a duplicate instance automatically. It is still initializing, and if I just go to the load balancer now, the load balancer will start reporting or start sending traffic to the third instance now. It will take some time, let's say. Okay, you can see the third instance is showing out of service because it is not performing the health check right now. It is booting out. After a few seconds, it will show insert, which means the load balancer will start sending the traffic right now. You can see it is showing in service now, right? And now, if I just check my DNS name of the load balancer, eventually it will start sending the traffic to my next instance that I've launched right now, a fresh instance. I have not done that. That's been done by auto scaling. Auto scaling. So I intentionally terminate one instance. Auto scaling group launch another instance to compensate for that loss. The load balancer starts sending the traffic to that extra instance that has been launched to compensate for the first instance that I terminated intentionally. So this is how it works. And for each and everything, you'll get a notification. So for example, termination, I terminated this instance, I got a notification. A new instance was launched, I got a notification. You can see this over here. Event auto scaling EC2 instance launch. For each and every event, it will trigger the notifications to me. So you can see the beauty and the power of the auto scaling or the automation, that once the instance gets terminated automatically, it automatically launches an instance, and the load balancer has started sending the traffic to it. This is completely automatic. Nothing has to be done manually. It is just that you have to perform the initial configuration. You can try this one out, see the recording, try this one out and see how it works for you. Any questions, any doubts? I'll discuss 2 or 3 concepts of auto-scaling in the next class because they are lengthier. I need to discuss the termination policies and all those kind of things, but I'll discuss that in the next class. Any questions, any doubts before we can wind it up? So that's it for today. I hope that today's session has been informative for you. We have discussed the ELB in detail and the auto-scaling group, and these are quite important topics. The agenda for our next class would be the EBS, Elastic Block Store. We'll discuss the CLI, S3, Glacier, Import-Export Snowball, Storage Gateway. And if the time permits, we'll also cover the CloudFront. So this is the agenda for our next or the coming week. We'll discuss the Elastic Block Store, we'll do the CLI, Command Interface, S3, Glacier, Import-Export Snowball, Storage Gateway, and the CloudFront. So these are the topics that we'll be covering in our next week. Yes, we are done with some theoretical, some basic concepts on the auto-scaling, but that will not take more than 20 minutes of the time. Some concepts on auto-scaling. 15 or 20 minutes maximum half an hour. So this is the agenda for next week. Okay. And if you somehow do the practical of the auto-scaling group, please don't terminate instances. What I'm saying is, if you want to wipe out, go to actions and delete your auto-scaling group so that it wipes out the entire instances. Okay. So if I delete the auto-scaling group, my entire configuration would be deleted, including the instances. Okay. So please, because sometimes I've seen that people don't delete the auto-scaling group and they delete only the instances. What happens is that once you terminate the instances, the auto-scaling group will automatically launch more instances. Okay, so this will, once I delete the auto-scaling group, it will automatically terminate my instances. Okay, so that's it. Any questions, any doubts before we can wind up? Oh, I'm sorry, I was deleting the launch configuration, right? I have to delete the auto-scaling group. No, okay, it's deleting right now. Any questions, any doubts? Okay, you can see my instances are shutting down now. So you have to delete your auto-scaling group so that it can remove the entire setup. Don't remove the launch configuration because it is just a template. It's not a resource. So even if you keep the launch configuration, it will not affect anything. Oh, this thing is still waiting. Okay. That's it for today. No questions, no doubts. So thank you so much, guys, for your time and patience. Have a great week ahead. And last but not the least, once this session gets over, please take out some time and fill in the feedback form, because yesterday only the same thing happened. Only 2 people managed to fill in the feedback form. It is quite discouraging. Once this session gets over, please fill in the feedback form, write down your comments, put it in your ratings, so that we can get to know your feedback. Okay, have a great week ahead. Please revise the concepts, study hard, and also come up with your doubt sessions, if any, in our next class. All right, have a great week ahead. Goodbye. Bye-bye.